Hello everyone, let's look at Leetcode question 94, Binary Tree Inorder Traversal. At the time of recording, this question has 13.1 thousand upvotes and 732 downvotes. The question is, given the root of a binary tree, return the in-order traversal of its nodes. Okay, so first the constraints, the number of nodes in the tree is in the range 0 to 100 nodes. And the values of the nodes will be between -100 and 100. Okay, so we have our first example here. We define the answer to be an array value of the in-order traversal nodes. We're going to return this at the end, and we keep track using a stack for the tree nodes of the in-order traversal. So we first do the outermost while loop and check, starting with the root node 1. Root is not equal to null. And the stack is empty right now, so here we have a stack. And we go to the innermost loop now. Then we say, okay, is root not equal to null? It's not, it's 1. So we push stack.push root, which is 1, to the stack. And we go root equals root.left, that's 2. Root is not equal to null still, so we add 2 now. Okay, and we do the same thing, push it, root.left, 3, it's not null. Add it to the stack, and you see then it's starting to look like an in-order traversal. 3, 2, 4 is going to be the first 3 nodes for the in-order list. And we've arrived at 3, it's topmost, and it says root equals stack.pop. Okay, so root equals 3 right now. And it says answer.add root.value. Okay, so answer then. Apologies for the handwriting. Answer is 3 so far, and it says root equals root.right. Root.right from 3 is null. So what we do then is go back to the while loop here. Root is not equal to null, or the stack is not empty. We do have stacks here. 3 has been removed because it's been popped, and we don't do this innermost while loop, and we simply pop once more from the stack. So 2 is now popped off, and it's answer.added root.value, so answer becomes 3, 2. And now we say, okay, root equals root.right, that's 4. Okay, root is currently 4. We go up to the while loop, root is not equal to null, that's true. The stack is not empty, that's true. Root is not equal to null, this is true, so we push then to the stack 4. So far it's 4, 1 on the stack. And it says root equals root.left. Okay, 4 to the left is null, and that is not the case here for the conditional. So we exit this innermost while loop and say, okay, root equals stack.pop. That's the 4 that we added. Answer.add root.value. 4. Root.right, that's null. So we go back up to the top of the while loop and say, okay, it's null, but the stack is not empty. So we continue. It's null, so we don't do this while loop. And then we just have 1 on the stack currently. Pop it off, and it becomes 3, 2, 4, 1, because we add it to the answer integer. And we do once more root.right 5. Root is becoming 5 now. Okay. We go to the innermost loop. It's not null, so we push it to the stack. The stack looks like this now. It's just a single 5. And same thing, we exit it because it says root.left. There's nothing to the left here. So we exit and pop it off. Root equals 5. Add it to answer. Root equals root.right. Not true. There's nothing to the right of 5. And now the root is null and the stack is empty. So we return answer. 3, 2, 4, 1, 5. Okay, so we have the same situation, different node values. We define our list answer as an empty array of integers, and then we define a stack of nodes, and we loop through the while loop outmost. Root is not equal to null because we start at root 1, and the stack is empty, but we just need 1 conditional to be true. We enter the innermost while loop, and we check, okay, root not null. Stack.push root 1. Root equals root.left. That is null. So we exit this inner loop. root equals stack.pop 1, answer.add root.value 1, root equals root.write 2. Root is now 2. While root is not equal to null, it's true. While root is not equal to null again, true. Stack.push root 2. Root equals root.left 3. Stack.push root 3. Root equals root.left null. Root is equal to null, exit. Root equals stack.pop 3. Answer.add 3. Root equals root.write null. Okay, so we don't do the innermost loop because root is null. We just have a single 2 now in the stack. So the stack is not empty. So we still are in the outermost while loop. Root equals stack.pop. That's the 2 left. Add, answer.add root value 2. Root equals root.write null. The root is equal to null and the stack is empty. So we exit both while loops, return answer. 132 is the in-order traversal. Okay, let's see the solution. And it ran. Very nice. So the time complexity of this solution is O of n, where n is the number of nodes in the binary tree. This is because we visit each node exactly once in the in-order traversal. The space complexity is O of h, where h is the height of the binary tree. This is because the maximum number of nodes can be stored in the stack at any given time, and it's equal to the height of the tree. That's it for this problem. Thank you for watching.